So let me start my presentation. The artificial object in the space tracked and cataloged by Space Surveillance Network. There are 800 cataloged objects in the geostationary region. However, in the present day, more than 600 uncatalogued objects are discovered in geostationary region. It is difficult to survey the uncatalogued objects because the total number and the location are unclear. The objective of this research is to establish the effective search strategy for uncatalogued objects and elucidate the environment of geostationary region. As the approach of this research, we focus on the breakup of spacecraft or rocket bodies. The breakup is a strong candidate of the origin of uncatalogued objects. The breakups generate many fragmentation debris. Breakup debris constitutes about 50% of catalogued in orbit objects. According to the past research, 2 breakups were actually confirmed. One is the Ekran-2 communication satellite, and another is the rocket body Titan 3C. Furthermore, 10 objects are suspicious to break up in GEO. Then, the process of the strategy are decided. First, survey fragments effectively by predicting the population and the motion of breakup fragments. Second, verify the unconfirmed breakup event by the origin identification of the detected fragments. Based on the above process, the effective search strategy and origin identification strategy for breakup fragments are proposed. There are 3 points in this strategy: planning and observation and verification. First, in planning, the target breakup event is decided and characterized for survey by space debris modeling techniques. One can get the information that when and where and how survey the fragments as the observation plan. Second, in observation, the optical survey is performed based on the observation plan. When the fragment is detected, its motion can be gotten. If the tracking of the fragment is a success, one can get the high accurate orbit. The orbit is used in verification to identify its origin. The origin identification of fragments is conducted effectively because the target object of the observation is decided in planning. The origin of the fragments can be used to verify unconfirmed breakup events or decide the target of the next observation. The characterization of the breakup fragments is a key technique of this strategy. To characterize the fragments, the target breakup event, the observation epoch, and the observation site. are needed as input. In the procedure, there are 3 steps to characterize the breakup. First, the breakup event is simulated and fragments are generated by NASA standard breakup model. The breakup is simulated 100 times by Monte Carlo runs. Second, the orbits of fragments are propagated until observation epoch. Finally, the population and the motion are predicted by propagated orbits statistically. So I will explain about planning in detail through actual planning. In this case, the target breakup event is 1968-081E US Titan 3C plan stage. Observation epoch is 1st March 2014. And observation site is Visay Space Guard Center, Okayama, Japan. The target, the Titan 3C, is confirmed to break up at 21st February 1992. First, we got the orbits of fragments at breakup epoch by NASA standard breakup model. The left figure represents about 240 orbits generated by one simulation. Actually, we got about 24,000 orbits by 100 Monte Carlo simulations. The right figures represent the orbits propagated until observation epoch. Second, the orbits are discretized, and the existence probabilities of case orbit, pk, are calculated in each beam, alpha I and delta j, by dividing the staying time by the orbital period, tk. Then, the population of fragments at the observation epoch can be predicted by existence probabilities of all fragments statistically. In this figure, 2 peaks can be seen. One is 358.5 and 4.5 degree, which is named point A. And another peak is 178.5 minus 5.5 degree, which is named point B. We can select the optimum observation point by its elevation from observation site. These figures are the time variation of the elevation of point A and point B. We cannot observe the elevation angle lower than 25 degrees from Visay Space Guard Center. So point A can't be observed, and point B should be selected. When the observation point is decided, each motion of fragments in the field of view at the observation point can be calculated. The motion vector can be calculated by the staying time, delta t, and the points where the fragment comes into point and goes out point of the field of view. After all motion vectors are calculated, the most likely motion can be gotten by this same way as the population prediction. The most likely motion is predicted by existence probabilities of each pin in delta x and delta y plane statistically. In this case, the most likely motion of 1968081E fragments is minus 15.3 and 1.8 arcsec per second. Then, I will explain about the detection system of Bisset Space Guard Center. In Bisset Space Guard Center, time delay integration method is used. This method can detect moving faint objects like asteroids by adjusting the rate of charge transfer in CCD sensor to the motion of faint object in field of view. In this method, one can need to set CCD rotation angle and TDI scan speed. CCD sensor must be rotated to match the direction of the motion of the object with the direction of the charge transfer in CCD. TDI scan speed, in other words, rate of charge transfer in CCD is set to be equal to the magnitude of the object's motion vector. If one wants to apply this method to the surveillance of breakup fragments, one needs to the motion vector of target fragments. Now, the motion vector of target fragment is predicted, so we can get this CCD rotation angle and the TDI scan speed. In this case, the CCD rotation angle is minus 6.7 degrees and TDI scan speed is 15.4 arcsec per second. The predicted motions of the fragment generated by each breakup event at the observation point are different in the population of the motion or the existence probability. So, one can survey the target breakup fragments selectively by set the CCD rotation angle and the TDI scan speed based on the predicted motion of the target object. Based on the observation planning, we actually performed the observation for the fragments generated by 1968-081 breakup. As a result, we detected 30 objects and got the orbit of 7 objects. The 7 objects were verified their origins by using its orbit. The origins were propagated until the breakup epoch and compared with the orbit of 1968-081E. As a result, 2 objects were correlated with the target. This object, X15300, is identified in high probability. We can identify the origin by the 2 ways. This figure represents the comparison of the inclination and ascending node vector at breakup epoch. The red disk is object's vector at each epoch through the propagation. Blue cross-shaped points are the vectors of the breakup fragments at breakup epoch. The breakup fragments has a special characteristic to be distributed in alignment. We can verify the origin of the fragments by judging whether the propagated orbit is on this line or not. In this case, the orbit is just on the line. Also, another index can be used to identify the origin. It is called pinch point. Pinch point is where the breakup occurred. These figures represent the comparison of the pinch point with the crossing point of the orbits. The crossing point corresponds with the pinch point at the light accession and declination and radius. Also, another object, which is named X15438, has a little possibility to be correlated with the target object. The I omega vector of the fragment is on the blue line, but it locates a little far from the center where the plots exist densely. Also, in the comparison of the pinch point, the light accession and the declination are in agreement, but the distance between the radiuses of each orbit is 400 kilometers. Then I move to the summary. I proposed the effective search strategy for breakup fragments using debris modeling technique and explain about the actual observation applying the strategy. As a result, 2 detected fragments were identified to the target object, and 1 fragment is correlated with the target object in high probability. Thank you for listening. That's all.